Hello everybody, get ready to do chapter 6 of SAT Math Level 2 preparation. And chapter 6 is about triangle trigonometry. You got 24 points, so we'll go into your notebook guide, have those out. And the objectives are solving triangles, law of sines, law of cosines, ambiguous case, finding area, and special angles. And then for your class worksheet, we'll have 6 points to go into that. And this is part 1. Let's get right into it here. Page 1 here. Trigonometry is often introduced in geometry courses in terms of the ratio of the sides of a right triangle. The right triangle in the figure below, let's see what that looks like here. We'll see that later. Has a right angle C and acute angles A and B. The sides opposite these angles are the hypotenuse C and legs B and A. So here we go here. So we had right triangle. Here's your right triangle. And it has a right angle C and then acute angles A. A is acute. And then B is acute. The sides opposite these angles. Here's your hypotenuse. And legs B and A. So here's leg B and then here's leg A here. The trigonometric ratios of one of the acute angles, say A, are defined as the following. So sine A equals opposite side over hypotenuse, or using symbols, be A over C. Cosine A would equal adjacent side over hypotenuse, would be B over C. And then tan A equals opposite side over adjacent side, so it'll be A over B. The mnemonic here is SOHCAHTOA, SOHCAHTOA, helps students remember these ratios. It derives from sine is opposite hypotenuse, cosine is adjacent to the hypotenuse, and tangent is opposite adjacent. When you use a calculator to evaluate most trig values, you will get a decimal approximation. The ratios of the sides of the two special triangles are shown in the figures. So here's one here. You got a 45, 45, 90. And you have a 90. And then this is a 60, 30. So this here would be a 60. And then this would be a 30 here. They call it a 30, 60, 90. So that would be what that would be here. This is your hypotenuse here, and then this side here has a length opposite this angle of square root of 3, which is 1 point something. And then this has the length of the side opposite this angle is 1, so that would be your 30, and then this would be your 60 down here. To illustrate how this can be done, suppose you want to find the trig values of 120 degrees. First, sketch the following graph. So here would be a graph here. Here is your 120 degree angle here. So we're 60 degrees in from this angle here. Here's a 60 degree angle here. Here's the side length opposite of your 60 degree would be the square root of 3. And then your 90 is to 2, and then this angle up here is your 30, and it would give you, they say x equals -1 here, but the length here of the side of the triangle would be 1. The graph shows the angle in standard position. The reference angle will be 60 degrees. Here's your reference angle here. And the side lengths for the 30, 60, 90 triangle. You can now use the definitions of the trig functions to find your trig values now that we have a triangle like that. So sine 120 would be y over r. Then we assign our side lengths to be square root of 3 over 2. Cosine 120 would be x over r, would be negative 1 over 2. And then their tan 120 would be y over x, which would be square root of 3 over -1, would be a negative square root of 3. All this is, we got these negatives here because we're in the second quadrant. saying cosecant 120 would be r over y. We just flip our sign here, and we get 2 times the square root of 3 over 3. And then cotan would be the opposite here of tan, and it'd be the negative of square root of 3 over 3. And then secant, our secant here would be the inverse of our cosine here. So it'd be instead of being negative 1 over 2, it'd be 2 over negative 1, which would be a negative 2. Values can be checked by comparing the decimal approximation the calculator provides for the trig function with the decimal approximation obtained by entering an exact value in a calculator. In this example, sine 120 would equal square root of 3 over 2, which comes out to being about 0.866. You can also readily obtain trig values of the quadrantal angles, meaning multiples of 90. The terminal sides of these angles are the x and y axes. In these cases, you don't have a triangle at all. Instead, either x or y equals 1 or negative 1. The other coordinate equals 0 and r equals 1. To illustrate how to use this method to evaluate the trig values of 270, first draw the figure. Here's your 270 degree angle here, and at 0, negative 1. First draw the figure. There's your figure. And then here's your figure. And then the figure indicates that x equals 0, then y equals negative 1 down here. 0, negative 1. Therefore, since 270 equals negative 1 over 1, the value is negative 1 there. For a value of sine 270 will equal negative 1. And then cosine 270 would equal 0, because now we have, instead of our here at sine, we have y over 1. Now we have x over 1 here. Our x value here is 0, so that's why we get that 0 value. And then for cotan 270, we have 0 over negative 1 as well. Cotan. Why? Because our tan equals 270 degrees, which equals negative 1 over 0, which is undefined. So our tan here is undefined, whereas our cotan would be 0 in that case. And then our cosecant, which is the inverse of our sine up here, is negative 1. So what's the inverse of 1 over, negative 1 over 1 would be 1 over negative 1, still equals negative 1. And then our secant, which is the inverse of our cosine here, when instead of it being 0 over 1, we invert it and we get 1 over 0, which is undefined. So our secant here would be undefined. An arbitrary triangle has 6 parts, so 3 angles and 3 sides. The labeling of the angles and sides of an arbitrary triangle is the same as described for a right triangle. Angles A, B, and C, uppercase, and their opposite sides are A, B, and C, lowercase. Typical problems in triangle trig ask you to find 3 of these given 3 others. There are 3 important theorems about triangles that are based on their relationships between the trig ratios and the angles and sides of the triangle. So yeah, consider the triangle depending on which sides and angles. So here's a triangle here. Depending upon which sides and triangles, or rather depending on which sides and angles of the triangle are given. So say the following formulas can be used to find the missing parts of a triangle. Recall from geometry that you can prove that 2 triangles are congruent if the 3 sides of the triangle are congruent to those of the other side angle side, or if 2 angles on one side of one triangle are congruent to those of the other, angle side angle or angle angle side. If you know 3 of these values, 1 triangle, then any other triangle that has the same three values must be congruent to the first. In other words, the other three values can be determined uniquely. The law of sines and law of cosines are two theorems that relate to sides and angles of a triangle. Law of sines is sine A over A equals sine B over B, which equals sine C over C. So law of sines is real handy that way in proving congruency. The law of sines says that the sines of the angles of a triangle and the lengths of the opposite sides are proportional. Law of cosines, a squared equals b squared plus c squared minus 2bc cosine A. So in this example here, we can flip values around. We can put our b squared over here and put our c squared over here. Then we have a resultant, what's left over here after we do that. So this will be our law of cosines here. And this goes in your notebook, students. There's a lot of notes in this lesson. There's a lot of establishing, re-establishing trig to you. If you need review on trig, I can provide packets to help you review trigonometry. No problem at all. Contact me at my email. The law of cosines is a generalization of the Pythagorean theorem. Since cosine 90 degrees equals 0, the three forms reduce to the Pythagorean theorem of A, B, or C as a right angle. The last term of each form represents the correction for A, B, or C not being a right angle. Since the cosine of an acute angle is positive, this correction is negative if A, B, or C has a measure less than 90 degrees. And since the cosine of an obtuse angle is negative, the correction is positive if A, B, or C has a measure greater than 90 degrees. I mean, this is what happens when you move different variables over to the left-hand side for the law of cosines. When the measures of two angles and a side are known, the third angle can be found by subtraction, and the law of sines can be used to find the other two sides as well. So you can start out by using law of cosines when you just have measurements, and then switch over into law of sines to find the two remaining sides and angles. So let's get into an actual example here. Solve triangle A, B, and C. If measure of angle A is 45 degrees. So here's our 45 degree angle here. 57 for B, and then the measure of A is 4. So here's your side measurement there is 4. So we need to solve the other angles and sides. Since the measures of the three angles sum to 180, we know that measure C is 78. By the law of sine, sine 45 over 4, 57 over B, and sine 78 over C. Therefore, these all equal each other. You have the same ratio. Therefore, B, side length B, which would be over here, is 4.74. And C, in this case here, this length here would be 5.53 for that one. If the measures of two sides and an included angle are known, use the law of cosines first to find a measure of the third side. Then use the law of sines to find a measure of the second angle. Finally, use the fact that the sum of the angles of a triangle is 180 degrees to find a measure of the third angle. So there's different ways of solving a triangle. And then we have B here, solve ABC, triangle ABC. A is 7, so here's 7. B is 12 down here, and then the measure of angle C is 62. So this is what we know. We need to find our other stuff there. And this is side angle side. We have side angle side. So by law of cosines, to find our length here of C, which is this length here, and it would be C squared, but we are taking the square root of everything. And this is all underneath the radical here, which will come out to be 10.68. By the law of sines, now that we know that, sine A over 7 will equal sine 62 degrees. So sine A here over 7 It'll be a sine 62 degrees over 10.68. So sine A will equal 0.5787, and the measurement here of A by that will be 35.36 degrees here. Finally, the measure of angle C here would be 180 minus AB, and now it comes out to 82.64 by that rule there. So we can find the measure of angle C here. 180 minus measure of A minus measure B. If the lengths of the three sides of a triangle are known, use the law of cosines first to find a measure of one of the angles, then use the law of sines to find a second angle. Finally, use the fact that the angle measures sum to 180 to find a measure of the third angle. So that one's always comes in handy when solving triangles. Solve this triangle here, A, B, and C. So now we have our side lengths, side. So how do we find the angle measures there? So by the law of cosines, we plug in our lengths here into law of cosines. We have cosine A equals this value here, which comes out to 0.9285. And so we can find measure A to be in 21.79 degrees. So now by the law of sines, sine B over 5, 21.79 for sine B, and that is over 3, so that equals 21.79 over 3. We know this and we know this, so we can set up a proportion here, and so the measure of angle B becomes 38.210 after we do our math here. And then finally for measure of angle C, be 180 minus 21.79 minus 38.21, and it comes out to being 120 degrees. So once we find two angles, we can always find our third angle. And that is lesson number 6, part 1, SAT Math Level 2 Prep, Animated PowerPoint Math Video at AOL.com for course materials or questions. Thank you very much.